All right, guys, let's go ahead and start the review. So the first one on the review and Alex. So I'm gonna do one of each type, and I'll skip around. I'll leave some for you, of course, but can't do all of them because they're just repetitive, and I don't want to use up too much time. But the first one is convert 1 degree, 38 minutes, 50 seconds to a decimal number of degrees. Okay, let's get started. Okay, here it is. So remember before we basically cut off or separate, not cut off, but do the minutes and seconds separately. Those will become decimal numbers that shall add to the degree. Okay, so basically think of this as a plus for each one. Then remember that the conversion is going to be, so I'm going to go skip a step since I've already done this before in a lecture. This will be 38 degrees. Oh no, I'll show it. I'll show it. It'll be 38. And then you change the minutes into 1 over 60 degrees. Then you change the seconds into 1 over 3600 degrees. There you go. So don't punch that into your calculator, add them all up at the same time. That way you don't have to have the rounding error. So you'll end up with did this earlier, 1.647 degrees. So 38 times 1 over 60 plus 50 times 1 over 3600 gives you this decimal right here. And then you round off. All right, let's go to the next one. Okay, so on this one, we're basically going to do the opposite. So what you do is take this piece, right? You just ignore the one part. Take the decimal and multiply it by this conversion factor. So technically, we're canceling the degrees right there. Right, so then this will give you, and you round to 33.78 minutes. Now take that decimal again and change that to seconds. So this is the decimal part. So multiply that by the conversion factor of 60 seconds per minute, right? So now the minutes will cancel, leaving you with, let me see, 46.8 seconds. So we're going to round to 47 minutes. So 1.563 degrees will become 1 degree, it's the original piece, plus the 33 earlier from here, that's minutes, plus your 47 seconds. So you just write it like this because it's understood. Okay, so the way you started, right? Ignore the degree, the one, the whole number. You deal with the decimal, convert that to minutes. And once you have minutes, you take the whole number for later, deal with the new decimal, convert that into seconds, then round off that part because we're not dealing with milliseconds, and then you're done. Let's go to the next one. Alrighty, let's convert this guy. So degrees to radians, or and radians to degrees. So multiply by the conversion factor. Remember that pi is 180. So we multiply it times 180 degrees, the conversion factor, canceling your pi, leaving you with negative 13 times 180 degrees over 4, which will become degrees. Negative 585 degrees. That's it. Part B, uh, same deal. We have 11 pi over 3. Multiply by your conversion factor. That'll leave you with negative 11 thirds, which is going to be, let me see. Yeah, I did this earlier, negative 660 degrees. Okay, okay. So here we're going, they wrote radians as a decimal instead of having the pi stuff. So it's going to be the same, just you have to use your calculator here. So 1.31 times, if I'm going to degrees, I need degrees on top, put the pi in the bottom. So I have to just kind of do this all at once. So the result will be in degrees. So calculator time 75.06 degrees. For this guy, I need to cancel degrees. So multiply by pi over 180, which is equal to, again, the degrees will cancel, but I gotta punch this into the calculator. So 303.6 times pi over 180, that gives me 5.30 radians. But anyway, that's pretty much it. Use the correct conversion factor. If I'm going to degrees, I need this one. If I'm going to radians, I need that one. All right, let's go to the next one. Okay, so on this guy, we're talking about coterminal angles. This is number 5. Uh, remember we said that I asked you to write down this formula or kind of a chart. I said depending on what location of the angle will determine how you approach it. Okay. Also, if the angle is bigger than 360, you have to subtract. So here they're kind of giving me a little hint. They're saying if the angle between 0 and 2 pi, that is coterminal to this one. So 19 pi over 4 means it went around once. Right, let's see, one, two, two, and then some change. So where does it end up landing? Well, it lands right here, which has an equivalent angle. So one thing you can do is change this to degrees and then start subtracting. Or if you're not sure how much to subtract, or you want to stick with the radians or degrees, just do 2 pi at a time. Here they're kind of just skipping and saying, oh yeah, just do 4. But like, why? Why 4? So I would do two at a time. So subtract 2 pi and see, am I still bigger than a circle? Is it still bigger than 2 pi? Subtract another 2 pi until we're within one revolution. It's easier to see here when it's in degrees. Notice how they went to the negative side, they want the coterminal side, the angle that is between 0 and 360 that's not negative. So just add 360 to this, this is what they're going to do, and you get the same angle. Okay. But that's pretty much all. I don't think we really need to do that on paper. Let's move on to some other one. Okay, so this one I think we talked about in class, or somebody asked about it. There's a couple of types, or there are different versions of this problem, but the idea is the same. So the way to get the area of just the red section is I got to find the total area from here to here using this formula, using this radius. That's what I meant by here to here. So, and then subtract that total using this other radius. So nothing's going to change except the radius. So you're going to do this 2 times and subtract. Okay, but just remember the rule says that theta has to always be in radians. And if it's not, like here, 76, you have to convert it. So let's go over this. So there's a formula. All we're doing is plugging stuff into the formula. Nothing crazy. So we need to convert 76 degrees to radians. So that we remember we just did that a bunch just a minute ago. Take the 76 and multiply by the conversion factor. We get this guy right here. So that's what's going to be our angle theta. Then we need the R. R is 115 for the large one. Let me see. Yeah, 115 for the entire sector, 93 for the smaller sector. So what you do to find the total is you find the area. See, they kind of did it all at once, which I think is a little confusing. So just remember, just do this one first. This gives me the entire slice. Gives me that's at some number. You can write that down, and then do it again with the other radius to get the inner part. Okay, so that's what we're gonna do real quick. What number was this? 6, I think. Yeah. But that's the idea. I'm sure some of you don't need to see the work, but let's go ahead and do it. Find the area of the seated region. A is equal to 1/2 r squared theta. And I'm just going to go ahead and use their conversion because they already did it. Theta is going to be, let's skip one step here, 19 pi over 45. Okay. Okay. So find the total area. That'll be with this formula. So A will equal to 1/2 times, and the picture had a radius of, or the large, they call it large, but I'm calling it total. Who cares? 115 squared times 19 pi over 45. To find out what that number is, Then find the smaller section where the people are playing the music area. A will be equal to 1/2 times 22 would be the radius there. So it'll be 22 squared times the same angle. And that'll give you a number. So subtract these and then you'll have the answer. That's how they get 8450.1. That looks ugly. Or round 8450.2. So that's all you gotta do. Fine, I don't have my calculator on me, so just find this number and that number, subtract them. Because you only want the seating area. So this is the whole entire section. This is where they're playing music, so take this one out of it, out of this. That's all. Okay, let's go to the next one. Okay, so this is number 7. Pretty straightforward. It says determine which one is even or odd. I gave you a formula that told you which one was which. So, and the way I remember it is the only one that's truly even is cosine and it's reciprocal. Everything else is odd. So I don't see cosine or secant, so odd. Then you have to remember the odd property. The formula says that if you have an angle that's negative inside, you basically pull a negative out in front and take the positive version. That's what odd lets you do. So that's it. Remember your properties. Have them on your formula sheet for your test. Let's go to the next one. Okay. So here, it looks uglier than or harder than it really is. They give you a formula, and all you got to do is plug stuff in. Honestly, I'm not going to do this one. Plug in G right there. Plug in V naught or V sub 0 right there. Plug in theta over here. Put in your calculator, see what you get. It's really all you're doing here. Let me show you. All right, they just plug it all in and you get this number. Just make sure that your calculator is in radians because they have a radian. Let's move on. Okay. On this one, again, it's another calculator question. So you just gotta make sure you're in degrees and then punch these in. Then you get your answer. Just round to the nearest hundredth. There's nothing really for me to tell you other than that. It's not too bad so far, right? All right, let's keep going. Okay, number 10. This isn't too bad, but you have to remember. Hmm. If they mention unit circle, then that means the hypotenuse has to be 1. So they said unit circle. Cool. And then they gave me this angle. So you got to basically draw this. So right here, part A. So go to negative 30, which is right there. We know P is 1, so hypotenuse has to be 1. The hypotenuse, I mean, the distance. And then just solve for A and B. Use a reference angle to find this guy here. So remember that your unit circle values are these. So use your circle, write down the X and the Y. And that's it, really. There's not much to do. It looks harder than it is, but if you have your circle and your properties, that's all you have to do. So remember, What is cosine? What is sine of negative 30? Find the location on your circle, and you pretty much have all these right here. A, B, and then the sine, cosecant, cotangent are going to come from the A's and B's. So it's all the same, presented in different ways. So the unit circle stuff, like where it came from, are the triangles. Like solving for the triangles is what created the circle. But I'm not having you memorize the circle or build it. So just have that at the ready. Have your circle. Okay, number 12, they said there's a ladder. Luckily, they drew us a picture so that we don't have to guess or overthink it. Got our angle right there of elevation. It's on the side of a house. The distance from the house is 9 feet. So how high is a ladder? So how high is the building right there? This section. All right, well, you need to choose which trig function to use. The ground. All right, let me write that down. Oh, you guys didn't draw this. That is pretty, of course. This is a triangle from the picture. So we got adjacent, and we want to know the opposite. I guess cosine or cosecant would work. Doesn't really matter. Because we know that cosine of 73 degrees is equal to the adjacent side over the hypotenuse. We know that the adjacent is 9, and I want to know. Oops, actually, I'm sorry. We want to know the opposite side. I don't know why I was thinking. Cosine's not a good one. Tangent or cotangent would be good. Tangent of 73 degrees is equal to the opposite side, which is what I want, over adjacent. There we go. That's much better. Multiply both sides by 9, and you get 1073 equal to 9 times this. These cancel, so now I can solve the opposite side. What is that going to be? I don't know. I don't have my calculator. Let me see. Look at the answer. It will be 29.4 feet. 29.4 feet. Excuse me. But remember, you have to choose the correct trig function and then just build it. Hopefully, if they give you the picture, it kind of helps a lot more. So I like to put the one that's missing up top, and that will kind of guide me which trig function to choose. All right, let's go to some other one, or the next one. All right, so here they're asking about cofunctions. This is number 13. There's not much to do as long as you understand this idea here. So they're basically saying, hey, pick your sine of whatever. Give me the cosine that is equivalent to that. And what you use is these formulas here, the cofunction identities. So that's all you got to do. So like, okay, well, This right here is the x or theta that's going to go in here because we're going to go to cosine, which is what they did here. They plug in the x, do some fraction work, simplify, and then that's it. 9 pi over 22. So they prove that this is equal to that by the 9 pi over 22. See, there's not much to do. Just use the formula here and remember what x is. Plug it in. Subtract the fractions, LCD of 22, in case you forgot. Change the fractions, and then that's it. Let's move on. Okay, so 14, you can give some information about theta. Oh, let me switch over. Excuse me. They're saying it's in quadrant four, and the sine at that angle is -4/7. So, and then they want us to find secant and cotangent. So complete the triangle. Theta is here, quadrant four. They're saying that the opposite side is negative. Hypotenuse is 7. Solve this side, that's going to be b equal to the square root, the Pythagorean theorem, of 7 squared minus this guy squared. I'm skipping a little minor step there. You should get 33. Yeah. Plus or minus root 33. So we're going to choose quadrant 4, the adjacent side, the x value. It has to be positive. Okay, so now we can just answer the question. Cotangent theta is equal to adjacent over opposite, so root 33 over -4, which is just negative, right? And then secant would be the reciprocal of cosine, so that would be let's see. Or we could say r over x, which is the same. 7 over root 33. But then we have to rationalize it, so we introduce the root 33 over root 33 in order to square the bottom. There we go. We got cotan, we got secant. So just whenever they give you them some info and they want you to find the trig functions, build the triangle, solve the triangle using your x squared. A squared was b squared, equals c squared. Find the missing piece, which I did real quick here. Choose the correct sign, plus or minus, depending on the quadrant. Remember we said x and y are positive or negative depending on the location of theta. And I gave you some formulas for this. So 4 means x is positive, y is negative. So x is chosen to be positive. Get rid of the root at the bottom, gets me to here. This one was already negative, -4/7. You always put the negative on the top, not the radius, because the radius is the distance, so that wouldn't make sense. Anyway, but that's all you really gotta know. Let's move on. Okay. So this is number 15. They want us to find tangent and secant given this information. So they're kind of trying to be low key about this. They're like, well, sine's negative, right? The y is negative, and cotangent is somehow positive. So the only way cotangent or tangent will be positive is if we're in quadrant one or quadrant three. But if one of them is negative, then they both have to be negative. Because remember, tangent and cotangent are ratios of sine over cosine or cosine over sine. So the only way this would become positive when it's over a cosine, right, would be if the cosine is also negative. Or vice versa, if this is cosines over this. So this is the two clues. The ratio of sine over of cosine over sine has to be positive, meaning the ratio of y over x has to be positive. That only happens quadrant one and quadrant three. Oops, sorry. There's some eating a cupcake earlier. That is some frosting. Yeah, it is. My bad. Okay. Didn't see that. Alrighty. So build the triangle like usual. Sine is negative 2 over 3, so negative 2 and 3. Do your x squared plus y squared equals r squared. We're looking for the x. This time I did it in general and showed the work. So x has to be plus or minus the square root of 3 squared minus negative 2 squared. This is root 5. And we're in quadrant 3, we said. So we gotta be negative. All right. So tangent of theta is y over x, or yeah, cotangent x over y, um, which will be negative 2 over negative root 5. Excuse me. Which becomes positive, but I still gotta deal with that root. So rationalize it, get rid of that radical. You get 2 root 5 over 5. Secant theta will be the reciprocal of cosine, or which is also it's also, let's see, the formulas, r over x, which is 3 over this root 5 thing again. So that becomes negative 3 root 5. We'll rationalize it, and we are done. But yeah, so from the top, this told us that we're this and this together told us we are in quadrant 3. You got to pull that information yourself and think about it. Once you have that, you'll be able to choose the correct plus or minus for your root. And then solve your triangle and just plug in the R, the X, the Y. You're good. Okay, so the next question, 16. We start going back to the graphs, which I don't want to spend, I didn't spend much time on it, but we did talk about amplitude. So the A in front of the sign, right, is the amplitude. The D moves it, shifts it up or down. On this example, all we have is a half in front, which is going to change the amplitude to 1/2. Okay, so you basically have to remember what the original looks like. Here's the original. Original amplitude is 1 to negative 1 when there's no number in front. Here, there's no number in front. Imaginary or invisible, I should say. 1's right there. Now, if there's a half, then the new amplitude will be half to negative half. So you can see right here, it's no longer 1 and negative 1 like it was here. The lowest peak and highest peak becomes a half. So we just graph accordingly. That's it. They just want you to do that. Now, what they do is they take all the easy unit circle values and just uh, cut them in half. So you can use your calculator, you can use your circle, you can use this basic idea of changing the amplitude, and you should be good. Nothing crazy. And I'm not going to put too many graphing types on the test. I'm going to reduce some of them in a moment. Okay. So here's the explanation for these. Remember, they're doing multiple things at once to your function. Remember what each of these parts do. This shifts the original graph down three. This changes its amplitude by a half, and this will create a phase shift. So what they do is they graph the original always, and then just transform it. Okay. So take the original and remember the 2/3 is going to affect the inputs. So if these are the inputs, then this will be the new inputs. So you can get easy angles. Then shift it down by three here. So first they do that phase shift part, then they deal with the amplitude, and then they shift it down by three. But again, I'm not going to put many of these. I want you to practice it on the homework and the review, but I'm going to keep these to a minimum, if any. But let's move on. This one here is more what I would like on a test because you're pulling information off the graph. So saying, oh, okay, well, what is the amplitude? What is the minimum? What is the period? So you'll have to use your formulas right here. So use this formula for period. Remember that the number in front is the amplitude, right? The A. And the B, if factored or already factored, will be the part you need for your period. Okay. To answer the question, when they talk about frequency or the full cycle, you're going to use your period. So check it out. Full cycle will be this guy. Let's see, 2 pi. So this is the B here. And then plug it into the formula. It's just the B is weird looking. And it's going to cancel out and give you 365, which it's supposed to. So you're basically using this. Oh, I'm sorry. This. So plug that B in, and you get your cycle. Peel off the A, which is right there. Give us our amplitude, 5.9. And that's pretty much it. Let's see, what else did they ask for? The minimum. Minimum is going to be here. Max and minimum values is the D plus the amplitude. Minimum will be D minus the amplitude. Just make sure you use absolute value. So they wanted the minimums, you just subtract it. So it's just formulas, but it's more conceptual. So understanding, okay, what is the period? What is the amplitude? And what does that mean? Right? Amplitude is the highest and lowest of your graph. In this case, it represents something in real life. Okay, let's move on to something else. Now, I posted the inverse trig lecture earlier. It's not going to be too heavy on this exam because we said we'd cover that after the exam. But I already sent it. But what I do want you to know is this is the basics. The inverse of a trig function gives you an angle. So this is like the opposite. So if you have, let's say you have tangent, you plug in an angle, you're going to get a value on the circle. Now, if you put the value into the inverse, you're going to get the location of where that happens. So basically, when is tangent -1? All right, so what you need to know is the domain and range of the tangent, which is right here. So make sure this is on your formula card somewhere, just in case. Then figure out, okay, well, tangent -1 is only -1 at uh, -π/4 because it has to go from here to here. So we go down -4, -π/4 to that location. If it was +1, then you'd go to π/4. So just go on, look at the circle and say, okay, where is tangent -1? It happens here. So I have to think it in terms of -π/4. It can't go all the way around because that would be outside the range and domain here. So I have to go the negative direction. So it's a very simple question. If you plug it into your calculator, tangent, this guy right here, you're going to get -45 degrees, which is the same as this. So you can use your calculator. I want you to use your circle just to kind of get a feeling for it because we're going to talk about that more after the test. Okay. Anyway, let's see what else. Okay. On this one, I did do this in the lecture and I gave you some examples and like basically like six, well, 12 formulas. It's more of a situational thing. So these, if sine inverse is on the outside and sine is on the inside, these will cancel out depending on what angle is inside, depending on this. So I gave you a list of when they cancel and when it's going to give you an error. Um, Most of the time you can just say, yeah, they undo each other. I'm left with this. Like 60, 70% of the time you could just do that. But you need to know when you can't. So look at those formulas, and depending on which one's on the inside will determine what the domains are. So for this one, I think we're good with any angle. It should be fine. Another thing you could do if you're not sure is do this. And say, you know what, let me do the inside first, get a number, right? If this is from the unit circle or a calculator. Well, unit circle because it's an exact solution. So once you have this, right, plug it into this function, the outer function, and then get your answer. So that's pretty much it. Um, think of it in two different ways. You'll cancel out or you find them yourself. All right, let's see. All right, that's pretty much it. I'm gonna post this and this will be your review. And we'll also talk about it in class too.